Assalamualaikum. My name is Irfan Hadi bin Muhammad Zulkafli.
My name is Muhammad Shafizal bin Masha.
My name is Nafiz Shamiz Zainal Azali.
So, our team will suggest a replacement sensor, which is conductive sensor, that would overcome the water leveling problem in culvert. Suggestion for level sensors problem to be used in culvert. So, our team has come up to choose for conductive sensors to be used in culvert to solve the level sensors problem. So this is the example of multi-level conductive sensors. Reasons of why using conductive sensors. First of all, eliminates false or inaccurate reading caused by residue build-up. By having a solid, cavity-free sensing probe with a homogeneous non-stick FEP coating, the sensor does not suffer from residue build-up in sludge and fall water, leading to an accurate liquid level reading. Second, no periodic cleaning or maintenance required. With no moving parts and no holes or cavities to block, there are not any locations allowing build-up of residue and solid. This means that accurate and dependable level measurement can be delivered without the need for scheduled cleaning or maintenance. This means that this conductive sensor has low maintenance. Third one, provides reliable measurement for difficult to measure conductive fluids. Unaffected by suspended solid and with ingress protection to IP69K, the 10,014 Blackwater sensors will work with any conductive fluids in any installed environment. Mechanically robust enough to be unaffected by stirred or sloshing fluid and suitable for use with corrosive or acidic liquids or additive. The sensor will continue to perform with even the most difficult fluids. The fourth one, low install and lifetime cost. Not requiring any additional mechanical support within the measured vessel simplifies installation, keeping the install cost to be minimum. With minimal maintenance requirement and no parts to wear or corrode, the sensor delivers an extended service life with low cost of ownership. And the last one, the fifth one, can be installed in all tank types, impervious to build up on vessel wall. By using conductive technology, the sensor does not rely on the tank walls for its measurement function, meaning that its performance is not affected by any build-up or deposit that may accumulate. Supplied with tank profiling functionality, the sensor can be configured for all tank shapes, providing a true volumetric output rather than a simple level reading. This means that the sensors can be easily installed anywhere, that easy for the sensor to scan the water level. So this is the conductivity sensor diagram. So you can see here the red and black is the lead wires section, and below is the secondary housing, and the last one is the conductivity probes, which is the probes is the section that which will sense the level of water.
Of the conductive sensor. Sensor position. There are three versions of conductive sensor. Firstly, we have sensor A. It's a single level conductivity sensor. This works with a metal tank that is grounded and used to complete the circuit of the sensor. When the water level reaches the probe, the sensor is then activated by having the ions in the solution complete the circuit between the probe and the tank. In sensor B, the tank does not need to complete the circuit. The ions in the solution bridge the two probes together once both probes touch the liquid. Finally, in sensor C is a multi-level sensor which can be grounded by the tank and also does not need to be. By having two probes at the same length, the tank will not need to be grounded. Each subsequent probe will complete the circuit in reference to the longest probe, allowing for multiple liquid levels to be detected on a single sensor. So, we can conclude that this sensor can switch on and off automatically. Second is sensitivity. Sensitivity of the conductivity sensor is determined by the ions charged particle in the fluid that can be sensed. Fluid conductivity is measured in unit of Siemens per meter. This unit of measure takes into account the amount of conductivity in the fluid across a given path length across the fluid. The common use cell width is 1 cm. Other common units of fluid conductivity measure include millisiemens per centimeter and microsiemens per centimeter. The unit of measure will change depending on the level of fluid conductivity, which varies considerably. For example, the conductivity of water can vary depending on its ionic strength. The figure shows a conductive sensor that has two electrodes, which measure the current flow across the fluid. According to investigation, the two electrode conductivity sensor perform well in low conductivity fluid in the range of 0.05 microsiemens per centimeter up to 20 millisiemens per centimeter, but are limited in their upper measurement and due to polarization effect. In the case of study, the sensor detects rainwater and sewage water with specific conductance of 40 to 67 microsiemens per centimeter and 500 to 2000 microsiemens per centimeter respectively.
Range and span. Range. It is minimum and maximum value of physical that sensor can sense or measure. For the span, it is the difference between the maximum and minimum value of input. For the conductivity sensor range are cover up to 0 to 200 micron Siemens per centimeter, and for the conductivity sensor span are cover from measurement span from 0 to 2 Siemens per centimeter, and accuracy and non-linearity error. Accuracy and non-linearity error consists of 4 types. It is for the first is measurement device, second one is electrode, the third is standard solution, and at the end is good laboratory measurement. For the measurement device, a meaning of error indicate the possible deviation of the actual conductivity of a non-calibrated measurement when the using an ideal electrode. The device error is the sum of two difference, which is repetition error and linearity error. For the electrode is a passive element which remain also the rather stable. Standard solution are consist of are used for calibration and the largest cause of error which cannot be eliminated. For the good laboratory measurement are consist of measurement practice allow to keep the error low. Error due to contamination of the solution, temperature difference, or not taking enough time. And at the end is for resolution. Resolution in conductivity is 0.1 micron Siemens per centimeter and 1 micron Siemens per centimeter, 0.01 millisiemens per centimeter, Next is 0.1 milli Siemens per centimeter, and the last one is 1 meter Siemens per centimeter. For the you can see is we get from info from reference link like conductivity accuracy from the attached link, and for the WQ conductivity sensor at the
Okay, so this is the drawing of the suggested conductive sensor positioning. So conductive sensor will be placed at the edge of the culvert. This is the culvert, and so this is the conductive sensor with two probes. One's the longer and the other one is the shorter one. So the longer one sense sense low level water at the bottom of the culvert, and the shorter one will sense high level water when the water decrease until it does not touch the shorter probe. The pump will automatically off as there is no conductivity due to no water.